Good morning, everybody. Welcome back to lecture number 23. Today we will talk about some important information about the exam. So we will have the fake quiz this Thursday covering the transformers. Remember, we didn't have quiz on the efficiency, we didn't have quiz on the voltage regulation, we didn't have quiz on three-phase transformers. I will post the solution today for the homework. Remind me if I don't so. Next week we will have the help session online. The EE Club will do it. So we'll find the announcement with the EE Club. Who's with the EE Club? All of you are 4 or 5 in the EE Club. So who's doing the help sessions? Do you know Luay? So arrange with him, please, okay? We'll do it virtual. I cannot do it in person. Not only that, it will be recorded. We will have the mini major, which is going to be, and it will cover everything up until, it's like the major.
Full class quiz.
Yes, full class. It's going to be full class quiz. Correction. Last time I told you we were going to have vacation after the major. No. We cannot have it, okay? Regulations do not allow that. So the makeup day will be after the vacation. We'll find one day, okay? Okay? So if you want to be absent, you can be absent. Those two of you, if you want to be absent, you can be absent. But again, you can be absent, it's your right, but I'll take attendance. That's the regulation. The makeup class will be when? After. We'll find a day. Or maybe one day you all want it. We'll have one day break. Don't worry. Another thing we have to worry about is the material of the major exam. It will be up until Thursday lecture or Sunday lecture, depending on how fast we go. DC machines are included in the major exam. So one question I might ask you in the exam, I will write a question. Did you watch the videos 5 times? You have to say yes or no.
This is a question.
It might be a question. This is my question. Did you watch the video? Video number 2. You remember video number 2?
Yes.
This. We're going to have questions, conceptual questions about the video. I will tell you, write a paragraph explaining in summary how DC machines work. So study the video.
And the mini major or the major?
Both.
قلبنا تعبير أقول قلبنا حصة إنجليزي.
Let me ask you a question. When you go after 2 years and you apply for an interview, they will tell you, explain to us how DC machines work in 4 minutes or in 3 minutes.
Yes. You remember Mr. Cook?
Then you remember the quiz or remember the major. The 360 is not only problems. I'm teaching you things in real life. What's the point if you know how to solve the problem and you cannot explain? You can have typos, you can have grammar mistake, I don't care. As long as you explain the concept. Okay? If you're not happy about it, then I'm going to bring very difficult math problems.
I think that they're very happy.
لا لم يهب.
So make your negotiations valid. So let me tell you how would I answer this question in the exam. I will tell you we will have a constant flux. This can be a permanent magnet or a stator with field windings. Focus. You may watch YouTube and write down these answers. The flux is going through a coil that, let's say for now, doesn't have electricity. But this coil is connected to a DC power supply through a commutator and the brushes. And I will have a DC current flowing inside the conductor. According to physics, I don't care about physics, we will have we will have an induced AC voltage on the terminal of the coil because it started to spin. because it started to spin, there is a force that would spin it from a DC. The moment it starts spinning, another AC voltage appears on the terminal of the conductor. Not the terminal of brushes, the terminal of conductor, the coil. Because it starts spinning, when it goes to 90 degrees, if we have one coil, it will not have any speed, and then because of gravity, it will goes down. So the movement will not be smooth. So to solve this problem, we need to add 4, 5, 6, etc. coils. However, from the brush's point of view, because of the commutator rectify that induced DC AC voltage. So it appears on the terminal of the brushes that we have a DC volt with ripples. So it is mixed. DC plus induced AC, even though it's called DC machine because the terminal has DC voltage. Yes, the terminal still has DC voltage. عشان الكميتاتر زي الدايود. It's a mechanical diode. Rectify signal. Do you remember rectify? What is the purpose of the rectifier?
AC to DC.
Okay.
Convert AC to DC. This is one of the interview questions. If we don't have these theoretical concepts in the exam, yes, you will get maybe a plus and 360, but you will fail the interview. You want to fail the interview or get C plus and 360?
C plus and C.
Get the C plus, okay. Get it?
Both, sharp.
Both?
الله يوفقك انت.
Okay? I'm serious, wallah. They ask questions like that. Explain how it works. And those people, they're way ahead of the game. They're better than all of us, including me, who ask an interview. Their job is to ask interviews. So they know what questions to ask. So please, when I ask you explain, don't be afraid. I'm not going to give you 0. It could be 4 out of 5, it could be 3.5 out of 5. But you have to explain it. The way to tell me that you did watch the YouTube videos, both of them. Okay? Now, there is another point. Classification of DC machines. Go to this figure. Now, do you remember this? What's the point of that? This is before the rectification. After the rectification, it is rectified from the alternating generated voltage. Quick question in the quiz or in the major, maybe. The induced voltage appears on the armature, field, brushes, commutator. The induced AC voltage appears in the armature, in the field, in the commutator, and the brushes.
Which one was the armature?
Because you didn't study. الارمتشر is the place where induced AC voltage occurs. لما يتحرك الكويل يصير في induction, induced AC voltage على الكويل. That's why it's spinning. الcommutator because it's rectified. Okay, which side we have the rectified voltage, induced voltage? Terminal voltage, you hit brushes. Terminals of the coils before and brushes. What's the nature of the output voltage? DC plus AC. After the commutator and the brushes? DC, rectified DC. If the motor is not moving, and the moment I connect the DC, do I have induced AC voltage just before connecting the DC? No. The moment it starts spinning. Another question. I'm going to ask you a question, for example. Mash'abi is having a motor and he's locking it by his hand. Will there be induced voltage in the armature?
No.
No. No, because there is no movement. I want you to understand this concept. Okay? Okay? These are the questions I'm going to ask in the test. It doesn't matter. املأ الفراغ. توصيل. I'm not going to have true or false. I don't like it. Because half of you will get it right, half of you will get it wrong. Maybe I'll have MCQ. Maybe I'll have explanation. Why? Why we need to replace the brushes every time? Because the brushes touches the commutator mechanically. Please, if you don't study the YouTube videos, you're gonna miss these conceptual questions. Please. Not the exam gonna be all the problems. It will be full of problems. Maybe 75% of the exam will be problems. But 25% of the exam, maybe 30, will be questions. إيش معنى؟ Remember, this is not EE 201 or Math 102. This is material, things, real life. So classification of DC machines. They are separately excited or self-excited. What does excite mean of the machine? إيش معنى excite?
Voltage and current, the right voltage.
Wrong. We're exciting what?
Energy.
Wrong. Wrong.
Power.
Wrong.
Start rotating.
Wrong.
Give it power.
We're exciting the DC magnetic field. هذا الاكسايتيشن. معنى الاكسايتيشن انه the moment I connect the stator to electricity, I excite the field and I have magnetic flux. هنا عندي how many poles? 4 poles. How many pole pair? 2 pole. I'm gonna have one DC flux this way, one DC. I'm gonna connect this to DC. هذه الاكسايتيشن. What is the excitation of the transformer? The moment I connect the primary to a source. If the transformer, primary and the secondary is not connected, there is no excitation. Excitation means you overcome the core losses and the magnetization current. The DC machine and excitations means what? Excite the coils in the stator to mimic the magnet. You have to study that way, please. Okay? These things are very important, but easy. Once you know them once, خلاص. إذا عرفتها مرة واحدة, you can continue. For DC machines, do you remember in the video, the last 1 minute of the video? Video 2? What did he say? He said we either excite the field winding with the same battery like the armature. This is we call self-excite. Or I separate the coils اللي على stator using a DC power source. With armature, I excite them. I connect them to another DC. So the first circuit is separately excited. This is the symbol of the armature. The symbol of the armature عبارة عن brushes ودائرة وbrushes. Then it may have resistance and inductance. And then here I have resistance and inductance, and here I apply VF. So is this separately excited or self-excited? Separately, logic. هذه separate ولا self? Self. The field has its own power. The motor has its own power. So in the motor, I have VA, where I connect the DC here. Electricity will flow this way to the motor, and the field current will move here. So this is separately excited. Self-excited, one way to have it is I have my armature. What is the armature? اللي هي الكويلز اللي تدور نفسها. Then I have resistor, maybe inductor, model. Then I'm going to have a field. So I apply the V field here. So if I apply the field this way, بيصير ايش؟ This is in parallel.
Yes.
Self-excited in parallel. Now you can have current source. You can have, the idea here is you're powering both of them using the same battery. Maybe the battery is here. Call it VA or VT, doesn't matter. Or you can have it in series. This is series, or you can have hybrid, compound. So going back to this figure, I'm explaining it to you and it might come in the test. Maybe I will bring you this diagram in the test and I ask you to fill it up. DC machines, I leave these empty. And I leave these empty. Can you do it?
Yes.
Would it be a problem trying to know these information? You don't like memorizing? Then understand. A smart student would not memorize. A smart student would remember. Okay, do I have separately excited? Then I have self-excited. Because we classify them based on the field excitation. A smart student would say, I can have them shunt. Shunt means parallel.
Okay.
I can have them series. You can have them mixed, compound.
كيف mixed؟
Compound, and you have, if we go here, you can have with our favorite photo, the real DC machine. You can have الارمتشر coils connected هنا مع brushes على بطارية. This field is connected in series مع البطارية.
طيب.
That one is connected in parallel. هذه next. Some of the one field winding is
واحد يكون برر واحد يكون سيريس.
yes. If you might have 4 poles, you will have maybe 2 series, 2 parallel. For 2 machines, it's better to have them either series or parallel. But if you have 4 poles, maybe 2 poles are series with the source. يعني you have البطارية.
طب هذا ما
هذه البطارية. You take the parallel. You take كيبلين من هنا على الفيلد وايندنج. Series. تاخذ one. تاخذه هنا. You take the output from هنا, then you connect it in series مع the rest of the circuit.
كذا ما راح يكون فيه مضارع على نفس
Depending on the design, this is beyond the scope of the course.
لأن البرر والسيريس حيختلفون في الفولت.
Yes.
طيب.
Everything is circuit is different circuit.
كذا راح يصير في تناقض مو تناقض يعني في اختلاف.
They can design it. They can adjust number of coils. الستيتر هذا يقلل الكويلات حتى انها تصير نفس الاوتبوت. They have their own games. It's EE462. Will teach you how to do these things. Okay? The idea here is you classify them based on the connection of the excitations. Keep in mind the symbol حق الارمتشر كذا. It looks like a voltage source. Why? What is the armature again?
هذا اللي
Wait, what is the armature? Did you watch the YouTube videos?
Not yet.
I don't like not yet. An armature is the place where we have induced voltage upon rotation. لما يبدأ يدور يصير في induced voltage.
يعني الكويل نفسه.
That's not the right terminology. لأن في كويلات في الستيتر نفس الشيء.
ممكن اللي يثبت هذا.
لو هذا البرش
البراشر.
الفحمات. الفحمات is not الارمتشر. الارمتشر is الكويلز اللي يصير عليها induced voltage.
اللي في الداخل كذا.
اللي داخل. في حالة الدي سي ماشين. When we talk about the AC machine, the armature هو الستيتر. Explain it later. But you know what's the armature? Is the place where the induced voltage occurs. عشان كده induced voltage سووه زي الفولتج سورس مع فحمات فوق. Okay? الفيلد, what did we say about the field? The field is a magnet equivalent. If you remember physics 102, they were talking about capacitors resemble electric field, inductors resemble magnetic field. Do you remember this?
Yes.
They kept saying it. That's why we resemble any device with magnetic behavior as inductor. Transformer, leakage. ليش حطيناها inductor؟ لأنها magnetic circuit. The field is the magnetic circuit. Plus add some resistors here and there for the copper losses. Okay? Question in the exam. Why we model copper losses as resistor?
Heat.
Because they appear in the form of I square R heat. Another question in the exam. Why we model the armature as a voltage source with brushes?
Induced voltage would be honest.
Because it is the set of coils that have induced voltage upon rotation. Please, those who will get the A pluses and the A's are the ones who study hard. I'm not going to open the old exam, try to find a trick, لعب في الكي، لعب في الفلكس، حط لي الترانسفورمر two parallel transformers ولا حط. No, I don't like tricks. To me, what I care about is understanding the material itself. Yes, فيها حل. فيها حل. Unfortunately, that's the bad news. So, for the equivalent circuit, an armature, we resemble it by a voltage source and a resistance. Voltage source عليه فحمات, okay? So it means when you do circuit analysis, you have to do plus minus E induced. But I'm not going to write induced every time. I'm going to call it E sub A. What does A stand for?
Aperture.
Armature. Same for here. RA, JXA, RF, JXF. Something like that. The field is a winding. والwinding عبارة عن coil. عبارة عن inductor. Plus resistance, we call it RF. When you reach this part of the slide, take a break and rewatch the video one more time. Because I'm going to ask you in the test. Please. There will be a big question. Explain how transformer work. Explain how transmission line work. Explain how DC machine work. What are the electric machines that we have studied so far? What?
Transformers.
Correct.
DC machines.
Yeah, but you have to be very specific. You should say we studied single-phase transformer, three-phase transformer, DC motor,
Transform.
separately excited DC motor, shunt. You have to elaborate. Tell me that you did open the slides and read the book and watch the YouTubes. That's the right way. Otherwise, C plus is better than not getting the job. What else I'm going to ask you in the test?
Did you watch the video?
Hmm?
Did you watch the video?
Yes, that will be. Yeah, but these questions will have maybe 0 grade. No. And if you say no, you'll be in trouble. It's better to say yes. Please watch the YouTube video that I posted, حق المachine. I want you now, every time you have a machine, the video plays in your mind. Because this video is a very good video. Very good video. And it's part of the material. Okay? Let's say that there is another circuit that has nothing to do with the armature. في armature هنا? This is a circuit that resembles a field winding, صح? Field. So usually we provide a current to a flux, to generate a flux. In this course, to make things simple, the relationship is linear. If I increase the current by 1 amp, I increase the flux by 1, say Weber, or milliweber. It's a linear relationship. So this is for a shunt DC motor, but this circuit is not important. Another question in the exam is, why do we have equivalent circuit models? It's written here. To assist the machine performance. Clear? Clear? Why we have circuit 1 or circuit 2 or circuit 3 for transform? To assist the machine performance. Is it a difficult question to ask?
دكتور انه قصدك ترفع الافشنسي حق الموتور يعني؟
No, assist يعني يقيم. ليش يصير عندنا موديل الكتريك سيركت لماشين؟ عشان تقيم اداء.
يعني عشان تعرف الافشنسي حقه مثلا او تعرف
Efficiency, voltage regulation, speed regulation, we'll hear it today. Okay? Let's look at the equations real quick. We started with this equation, E induced K times the flux, but the flux is DC, so max RMS is the same, times omega. What's the unit of omega? Radian per second. Now, I told you it's a linear relationship with the field current. Can I do it this way?
Yes.
Yes. Yes. Now, can I, let's say using this circuit, can I do a KVL? Yes, voltage rise or voltage drop?
Right.
VA, this is the KVL. Minus, let's say it's only DC, so if it's DC, what is the impedance of the conductor? 0, صح? So J omega. L, what is omega? 0, it's DC. So minus RAIA minus EA, right? Can I do my trick?
Yes, yes.
Get it? That's how we got this equation. And this is valid for every armature circuit. This armature, you do the KVL here or here, but here you have series with F, you need to add F. Keep in mind it's DC circuit, so we do not have inductances. Okay? And power, do you remember this equation? This torque is same as tau. نفس التau. Okay? Write a note. T is tau. T is tau. Equals EA times IA. So basically, in the motor, I'm having a shaft. This shaft would spin. Torque times omega, or tau times omega, equal EA times IA. هذه الاوتبوت باور حقت الموتور. Quick question. Can I write the torque as function of flux? Yes, it's K times flux times A. We did this at the first lecture. Can I write it as a field current? Yes. So I can know that the torque is controlled by changing the field, changing the IA. How to change the IA? Change the terminal voltage. You apply power here. If you increase the voltage more, power can be transferred to load. But the problem with DC machines is if I get Mash'abi, for example, putting a heavy box on this machine, it will be slower. Or it can stop completely. لحطيت يدك ما يتحرك. But the electricity will try to push. So the control of machine, it's two-way. It's a function of the mechanical load plus function of the electrical parameters. So yes, you may increase the torque by increasing the current or the flux, but I don't know my load. Could be a heavy box, could be a light box. أنا أضرب مثال البوكس كأنها بكرة تدور. If I have a ممكن الماشين is not rated على البكرة وتوقف. لها علاقة بالجاذبية، لها علاقة بالاحتكاك وأشياء زي كذا. What you need to know is I can write an equation to resemble the speed. Do you remember this? Isn't this EA? Can I write EA equal VA minus IARA? Can I divide K with flux? So here I can increase the terminal voltage, provide bigger supply. Okay? I can increase the armature current. How do I increase the armature current?
Is the voltage.
Depends على اللود.
إيه قبل اللود.
Think of it. Do you remember السيارات هذه حقت السباق؟
اللعبة.
إيه. سيارات اللي الموتر حق.
الريموت.
بلاش الريموت اللي تضغطها وتمشي.
أوكي.
اللي تدور في الحلبة. If you hold it by hand, would it move?
لا.
No.
But would you feel more current, more heat? Yes.
Yes.
If you let it go, would the current become less and become cooler? It's something like that. You are not required now to know everything, but you need to know that the speed gets impacted by these parameters. Even if I change the design of the machine, if I change number of poles, I'll change the speed. But from electric circuit point of view, this is valid.
الار اللي هي جاي من
ال RA هي resistance. RA.
طب اللي جاي من اللود كيف حركه؟ ولا ما تحسبها الحين؟
We will explain. Usually load, you use the equation torque times omega equal EA. The load can be identified by torque. Then you know speed. If you know torque, you know the voltages, you can calculate the speed. If you know the speed and the torque, you can get the voltage. Something like that. We'll solve example. But for now, what I want you to know is if Mash'abi kept holding the motor, the equation is still valid. The speed is 0. It means VA equal IARA. Okay? And then IA has to be constant. If I let it spin more, of course the flux will change. And it depends. Is it separately excited or self-excited?
بس هنا دكتور مو قال التورك في المعادلة.
Yeah, because the torque will appear here later. We will solve examples. And you don't rush things. Torque له علاقة بال EA times IA tau omega. Omega hat is different. يعني this is another way of using the omega. But before we go, what's the unit of omega? Can I convert it to radians per minute? Multiply by 60 seconds over 1 minute. Can I convert it to 1 revolution? How many pi? How many radians? 2 pi. So if I multiply it by 1 revolution over 2 pi radians, what's the ultimate unit? 60 over 2 pi in
Configuration there. Ready? Configuration.
See, this is omega equal to n. What's the unit of n? RPM. What's the unit of omega? So to convert omega to RPM, multiply by 60 over 25. How about if I want omega? It's 2 pi over 60 times n. So speed regulation, do you remember speed regulation? Time is up, we'll talk about speed regulation, but in summary it's V full load minus V no load over, it's same. Speed, no load, it means it's spinning without any load. Speed with full load means we put full rated load, rated box. You can get it in either omega or RP. We'll continue using this lecture next. Any other question? You can go please if you want. Any question?